Hey y'all, how you doing? We're going to use manipulatives to reduce fractions today. If you don't have manipulatives, don't sweat it. Just look at the pictures that are in the book starting on page 133, and we're just going to compare these. And what we can do is very quickly compare fractions. And let's go with, you'll just see this. Okay, let's go 4/8 first. I'm going to divide this pi into 8 perfectly. It's awful, isn't it? All right. Then I'm going to go 3/6. Oh dear. Here we go again. Oh, I'm terrible at drawing that. Okay. And pretend those are all equal pieces. Fourths, that's the third one. So I'll do that in the fourths. And then 1/2. Okay, that's half. Well, we can go, obviously 1/2 is like that, right? Even though it looks like it's farther to the left than it should be. 2/4 will be this much, right? 3/6, there's 1/6, there's 2/6, and there's 3/6. 4/8, there's 1/8, 2/8, 3/8, and then 4/8. Okay, and you can see obviously that all these fractions are the same thing. In fact, if you reduce what goes into 4 and 8, well, 4 goes into 4 once, 4 goes into 8 twice, 1/2. Same thing for 3/6 and 2/4, right? So visualizing those fractions is sometimes helpful. Okay, they'll say reduce 2/6, reduce that number. Well, all you need to do is you could go, you could, if you wanted to draw a picture, you could do that. And, okay. 2/6 would look like this. I'm just going to do 2/6. Okay. So each one of those, I mean, reducing, you can either do it in a way as far as looking at pictures and saying, okay, it looks just like the 1/3 I have in my manipulative, or you can just take these numbers and knowing your factors and knowing your division and multiplication tables, you can reduce the fraction. What's the biggest number that goes into 2 and 6? The answer is 2. Goes into 2 once, goes into 6 3 times. That's it, reduce. All right? 2/3 of a circle is what percent of a circle. Now again, if you have manipulatives you can mess around with and look at them and do that, that's fine. To look at this problem and go, oh no, how do I figure this out? Remember, of means what to do what in math? To multiply, right? So you could say 2/3 of a circle is what percent of a circle. Well, what number are we using when they say the word percent? I'll give you a little hint here. Hold on. I'm not going to give it away. You have to fill in the dots yourself to connect it. Okay, yeah, 100. Okay. So in other words, what are they asking? 2/3 of 100. When you hear somebody say 2/3 of 100, what arithmetic problem do you see in your head? You should see this. 2/3 of 100. That's what you should see. Okay. Now that's over 1 if you want to. What you can do is you can go, okay, well, I'm just going to go across here. 2 times 100, that's 200. 3 times 1 is 3. And that is, every fraction is a division problem. What is 200 divided by 3? I don't know. Let's see what it is. Let's do the division, right? 3 into 200. Let's do this in short division. 3 into 20 goes 6 times, right? What's left over? 2, right? So that's done. We're messing with 20 again. 3 into 20 is 6. 6 times 3 is 18. What's left over? 2. Okay, well, what fraction do we write if there's a remainder of 2? 2 goes on the top, 3 goes on the bottom. There you go. That's it. All there is to it. Okay. How about 1/3 of a circle? You would just go, oh, I'm going to go 1/3, of a percent, my bad. Of 100%, there we go. You do that, that's a 3. If somebody said to you 2/9 of, what percent is that? You do the same thing. 2/9 times 100, you do the same division and you write it up, and there you go. Okay? 2/6 of a circle is what percent of a circle? Well, same old thing, right? When you, and again, I hope you're training yourself to say, when somebody says to you 2/6 of, blah, 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 percent, that means of means multiply. Excuse me. 2/6, you know what that is. And what percent? Oh, that's going to be times 100. Now, very quickly, you can do two things here. You can either do this outright like it is and just whatever, or what you can do is go ahead and reduce this fraction immediately before you mess with this to make it easier on yourself. I think I would probably reduce it first. So 2/6 is a third, right? So what's a third of 100? 1 times 100 is 100. 3 times 1 is 3. Don't forget, every fraction is a division. Rhymes with problem. Okay. 3 into 100. Let's do this in our heads. Ready? In other words, we're going to go 3 into 100 in our heads. 3 into 10 is 3. There's 1 left over. 3 into 10 again is 3. And there's 1 left over. Okay, the 1 goes on the top. The 3, that goes on the bottom. There we go. That's all there is to it. Division problems. Okay. Susan ate 5 3/4 pizzas one day, then ate 4 3/4 pizzas on the next day. How many pizzas did she eat over those 2 days? Not how many she kept down. How many she ate. Okay, those are 2 different things. All right. Lots of peppermint oil. How many gallons of peppermint oil did her mom sprinkle, into a cup and make her drink before she threw? Oh, never mind. Okay. Well, here we go. All we're doing is saying, okay, 5 3/4 plus 4 3/4, right? So either, well, let's just do the integers first. That's a part, and that's another part. This is a mixed number, right? The integer is here, the fraction is there. Let's just add the integers first. 5 plus 4 is 9. Then 3/4 plus 3/4, you know very well, is 6/4, right? Okay. Well, let's look at this part and go, well, we need to figure that out. What is 6 divided by 4? Because I might have mentioned this once before, but every fraction is a division. Okay, yeah. 6 divided by 4, of course, is going to be 1, and then 2/4 left over, right? You could also say 2/4 is just 1/2. So you could go, no, I'm not going to write that. I'm going to write my 9, and I'm going to add it to 1.5. So obviously that's 10.5, right? 10.5 pizzas. There we go. And 10.5 drops of peppermint oil down the gullet. Okay, keep those pizzas down too. All right. Okay, let's try another one. Subtract 1 2/7 from 4 5/7. Piece of cake. They have the same denominators, right? And make sure you're doing this correctly in the right order. You're subtracting this from that. So that number goes first. 4 5/7. Subtract that. Subtract 1 2/7 from that. All right? Pause it yourself and give it a whirl and come back. Okay. Well, the integers subtracted from each other will be 3. Then the 5/7 minus 2/7 is 3/7. So there we go. That's all there is to it. Okay. All right. Give the practice set a whirl. It's on page 135. And there are A through H. So try 8A and give it a whirl. Pause your video here. All right. Hold on. Let's try this again. Go ahead and do A through H. Do all of them and then come back and we'll do them. You don't have the manipulatives for the first 2. It's no big deal. It doesn't matter. So do all A through H and then come back and we'll do it together. Okay. A and B are 1/4 and 3/4. Adding these two, 12.5% plus 12.5%. Well, that's 24 plus 2 halves. Well, 2 halves is 2 divided by 2, right? In other words, 24 and 2 halves is what you might have written. Well, 2 divided by 2 is 1, right? So 24 plus 1, 25%. For D, 83 and 1/3. Now that's interesting. That you would have got 82 and then 4/3. You probably ended up with that at first. But don't forget, 4 divided by 3, because every fraction is 4 divided by 3 is the same thing as 1 and 1/3, right? So you do that instead. Well, 82 plus 1 is 83 and 1/3. There you go. All right. E, 6.5. Excuse me, 6 and. That's not right. Oh yeah, that's right. Yeah. So that's basically 5. You might have gotten 5 6/4. Well, 6 divided by 4 is 1 2/4, or I would say 1 1/2, and that's what I would add to the 5, 6.5. There you go. F is 4. Should have been a piece of cake. 3 8/8. 8 divided by 8 is 1. 3 plus 1 is 4. 5 2/3 and 4 3/4. There you go. Piece of cake. Okay. Have a great time doing all the problems today. Do the best you can. Have a good day. See you tomorrow.